On Friday, we discussed 2, 3, and 4. I think that assignment did not get posted, so I did post it on Sunday, and then today we're going to add to it, but they're listed as separate assignments. So this is Monday's assignment, and I know it feels like you're getting doubled up on here maybe a little bit. But the new one, the one in blue there, listing rational roots, it's going to be real simple. Just like 2, 3, and 4 when we looked at them on Friday, the only one that really took time was that guy, and maybe this graphing and finding the zeros because you had to pull up Desmos to graph them. The video is posted on that though, so if you need help with 2, 3, or 4, take a look at that video, and that should help you out. Today's stuff, we're just going to list the rational roots. Now, if you recall, on Friday, what we did talk about theorem. The rational root theorem, it reads kind of crazy. It's difficult, I think, for students to understand, or most people to understand when they first read it. And what it says is that if you have a polynomial, so they've written this polynomial crazy, it just means it could be of any length. The key things are it's written in standard form, and a sub n is the lead coefficient, and a naught here, a with a little 0 below it, that's read a naught, or a ought, or a sub 0. But that, the last term, because we're in standard form, is the constant, so it has no variable with it. And so if you got this polynomial, okay, and I've got one written down here, f of x. If it does have solutions, rational roots, zeros, x-intercepts, so if you set it equal to 0, if it does have them, then though one of those solutions, or more than one of those solutions, is going to be p over q, where p is the factors of the constant term, and q is the factors of that lead coefficient. Now that sounds pretty complicated, but it's going to be relatively easy to do. So in this case, all you have to do is you list what the values of p are. Now p, again, is the factors of this constant. Now the constant is technically -6 here, so let's put a square around that. So we just list all the factors. Now when you do this, you want to list all the positives and negatives that divide evenly into it. So 1 goes into 6. 6 is divisible by 2, it's divisible by 3, and it's divisible by 6. So that's the values that the numerator could be in these solutions. The q comes from the lead coefficient. So q, what's 2 divisible by? Well, it's divisible by 1 and 2. And therefore, the possible solutions, if it does have a rational solution, it's going to be the ratio of all these p's over all these q's. Now you have to do all the combinations. So you have to do 1 over 1 and then 1 over 2, and 2 over 1 and 2 over 2, and 3 over 1 and 3 over 2, and 6 over 1 and 6 over 2. And I'm going to write these out without simplifying, and then we'll show you how you can simplify them. So you go the green 1 over the red 1. And then you go comma, and you go the green 1 over the red 2. Then you go green 2 over red 1. This takes a while when I'm trying to write all these colors correctly. Then the green 2 over the red 2. Hopefully you're getting the idea now. Then we do the 3 over 1. I'm not going to switch colors anymore. The 3 over 2, the 6 over 1, and the 6 over 2. Now, in general, when you write these, you also try to simplify them in your head at the same time. So, for example, 1 over 1 is just 1. 1/2 is a half. But 2 over 1 is just 2. 2 over 2 is again 1, but we already have 1 in here, so we don't have to put it as a repeat. Then we got 3 over 1, that's just 3. 3 over 2. 6 over 1 is just 6. And 6 over 2 is 3 again. 6 divided by 2 is 3, and we've already got that, so we don't list it. And so there's all the possible solutions that are rational to this equation. And if you think about it, that's very powerful because obviously with a graphing calculator or Desmos, we could figure out which ones it is very quickly, and we're going to do that. But without a graphing calculator, we have just eliminated a whole bunch of answers and narrowed it down. If you think about an equation like this when it's equal to 0, we would have to check every single x if we were playing guess and check. It's an infinite number of choices. But now we've just narrowed it down to a possibility, I think that's 6 different numbers, so pluses and minuses, so there's 12 now that we do have it narrowed down to. So let's look at how we're going to do this in our homework. Okay. It says list all the possible rational roots, that's what we just did. And then we're going to throw the graph in and just see if we can find ones that actually are solutions. Okay. So let's do our P's and Q's. So our P's come from the constant. What divides into 21? Well, 1 does. It's divisible by 3, divisible by 7, and divisible by 21. Q is 5, the lead coefficient, 1 and 5. Now we list all of our combinations of P's over Q's. 1 over 1, 1 over 5. I must simplify as I go. 3 over 1 is just 3, and 3 over 5. 7 over 1 is just 7, and then 7 over 5. And then 21 over 1 is just 21, and 21 over 5. So if it has a rational solution, a nice number that can be written as a fraction, it's one of those. And now what we're going to do is we're going to graph it. And I've got that graph set up for us here, so let me slide him in. Let's pull him over here. And we can see in the graph, it's giving me 2 zeros right there and right there. Now, again, with a graphing calculator or with Desmos, we don't know if those are exact solutions or if they've rounded it. But we can figure it out now pretty quickly. I'm going to use the positive one here just because it's easier to deal with. Okay, that is 0.775 or 775 thousandths. Remember, it goes tenths, then hundredths, then thousandths when we're reading decimals. So we just write it that way. And I'm going to simplify this. Let's see, they're both divisible by 5. 5 goes in 7, 1. So 155 over 200. See, these are both divisible by 5, so it's 31 over 40, and that's it. Now, if I go in here now and I look to see if that is one of my solutions, none of these are 31 over 40, okay? That means that this answer that we found, that thing's not correct, okay? And this number, 0.775, must have more decimals behind it. We just don't know what it is. So we can just put none of these work. That's kind of disappointing, okay? We'd like to find some of them, but it just means that, all right, this equation has no rational solutions, therefore we're going to have to go hunt them down with some other methods. We aren't going to worry about those methods yet today. Let's look at another one that does have some nice solutions. Okay, so here's my equation, and I'm going to list my P's and my Q's. So P again comes from the constant. things that go into 8 evenly. Here they are. And then Q comes from the lead coefficient. And then here's all my possible solutions. 1 over 1, 1 over 5. Oops. 2 over 1, which is 2, and 2 over 5. 4 over 1, which is 4, and 4 over 5. And 5 over 1, which is 5. And 4 over 5, sorry about that one. 8 over 1, which is 8. I put my p's on top. And 8 over 5. So there's the first part. List all your possible solutions, or rational solutions. I'm going to pull in the graph again. Zoom in here a little bit. All right. In this graph, when I did it, it only crossed in one point. It crossed where x is equal to 0.4. That is 4/10 or 2/5. So it looks like if it does have a rational answer, it is 2/5. Let's check to see if it's in our list. Aha. Oops. There it is. Positive 2/5. So we do know it has one rational solution. That's the positive 2/5. The rest of these just don't work. Okay, so our graphing calculator checked those for us very, very quickly. And now this thing still has 2 more solutions, but we know they're not rationals, and now we would know that we can go in and use some other methods and techniques that we have to solve it. But that's it. Now today on your assignment, what I've done is I've given you guys the function, okay? And you're going to list your p's over q's. So you're going to have to find your p's, find your q's, make all the combinations. But then I've also already given you the graph, so you don't have to go to Desmos. You just have to look at the graph and figure out, hey, which ones of these are actual solutions to the rational solutions to the equation. And so when you get done, you'll have something like this, and your graph, which is already shown for you, you don't have to redraw it, and then your solutions. It could be one or maybe more of these work. Okay, if it's 3 of them work, fine. You put down those 3 answers for x, and that's it. Pretty straightforward. Is I gave you a polynomial, and I said, hey, find the rational roots for this thing using the graph, and we could just look at it, and we could immediately tell what the rational roots were most of the time. So like this one, it's 0.2, but we said rationals we want to write as a fraction ratio, so that's 2/10, which is 1/5, whereas this one is just 1. So we could just go over here and say, x is 1/5, x is 1. Now, the 1 we said on Friday had multiplicity of 2, just meaning it hits it on the way down, and then it hits it on the way up, so it counted as 2 solutions, giving us a total of 3, because its degree is 3. And today we're doing exactly the same thing, except we're doing one pre-step. And that pre-step is called the rational